MCT4C day 22. Yesterday we were adding vectors, today we're subtracting vectors. And the first question in the 3-minute review just asked us to write one as the sum of the other two. So, you know, they're kind of pointing all over the place. But what we look for is we look for a triangle rule or a parallelogram rule, clearly triangle rule. And the rule is we write them tail to tip. Right? Tail to tip, right there, tail to tip. So these two have been added, x plus m, and that's equal to g. Done. Next. That was tail to tip. That's why we chose it that way. Refer to the diagram in 1. Draw a vector that is equal in magnitude but opposite in direction to m. So we want to draw the opposite vector to m. Well, I can do this. You'll have to just eyeball it on your sheet, but there it is. Well, that looks like a vector that's the same, but I'm going to put an arrow on the other end. Smartboard magic. There. And that is vector negative m, the opposite to m, which leads us right to today's lesson, which is subtracting vectors. Makes sense. We were adding vectors, we're subtracting vectors, and this hopefully will be quite natural for us. To subtract vectors, to subtract integers, what do? We add the opposite. So to subtract vectors, we add the opposite. That's the whole rule. And we'll see what that looks like for vectors in a second. So when we see subtracting vectors, what we're doing is we're adding the opposite vector. As far as the notation here, you don't have to worry about it. This is more something we do than something we write. Okay? And here we go. So we've got two diagrams because we've got two questions there. U minus V and V minus U. So where's a vector that represents U? So it's U first. U is the positive one. There's U right there. Let's say that's U. I should be using a vector here. Right there, vector U. And then I want to add negative V because U minus V. So negative V is a vector that's going in the opposite direction that has the same magnitude. That looks about right, eh? Opposite direction, same magnitude as V. And so I'm going to put that in place. And this is vector, that's vector, oopsie, negative V, isn't it? So when I'm subtracting vectors, I just wrote the negative, and this is one of the rules from yesterday. Now what do I do to finish it off? I start at the start and end at the end. That vector there, should have used a ruler, I guess, represents U plus negative V, but we would never ever write it like that, right? That's U minus V. And that's it. Now, which rule did I use from yesterday? Well, it's a triangle rule, right? I went U and then plus the opposite vector of V, and that's actually how we subtract vectors. We're going to practice it again here, and actually I'm going to, just for fun, I'm going to use the parallelogram rule. So the positive one is V, and I'm going to write V down here. There's V. Nope, yep, that's what I want. There's V. Mess. There's V. And negative U, I'm going to draw, I could think of it over here, is like that, right? Same magnitude, opposite direction. And I am actually going to place that. Darn, I've made a mess of this, haven't I? That's okay. because I can do this, I am. I'll try and get it out of the way, so if you started your diagram same as me, it'll be out of the way as well. Remember, vectors don't matter their position. So there's the vector v, and here's the vector minus u. And I place them tail to tail, right? Because that's another thing we can do when we're adding vectors. Because I'm going to try the parallelogram rule here. So I drew the two vectors, negative u and v, tail to tail, and then I'm going to pressing, I just got to copy this so it goes up. And then I make a parallelogram, right? And for parallelogram rule, you start at the tails and end at the tips. That vector right there is v plus negative u, or v minus u. One thing I want to mention here, these two vectors aren't equal. Right? Watch. I'm going to grab, well, maybe we'll grab this one. Can I grab this one? Yeah, sure. Grab this one. They're the same length, but they're in opposite directions. Yesterday, when we went u plus v and v plus u, they were the same vectors. Triangle rule, parallelogram rule, they were the same vectors. But here, when I subtract, I don't get the same thing. So I'm going to say, note, u minus v is not equal to v minus u. Okay. Express one vector as the difference of the other two. Okay, well, how are we going to do this? Well, pick one as a negative. Notice if I write g this way, then I could go m plus g, but then I'm not starting at the start and ending at the end. So I can't make g opposite. I'm thinking about making one of these opposite. So let's try to make m opposite. Let's go the other way for m. So this purple vector is negative m, right? And now notice what I've got. I've got g and negative m equals x, don't I? So I got, I'll just use this one, g plus negative m is equal to x. Well, there it is. This is the difference of two vectors. X is g minus m. And I just did that right on my diagram by messing around with negatives. Now, I want to mention something here. From the 3-minute review, we had this statement, the same diagram. Hopefully you notice that. Say, well, can't I treat this like an equation and just, take m away from both sides? Am I allowed to do that with vectors? And indeed you are. And this is one way that some people sort of get through all this, that they can't see the pictures as well, but they're good with arithmetic and they're good with equations, so that also works. I could have written a sum and then just rearranged it as a difference. That's possible. Okay, example 3. Rhombus, x is the intersection point of the diagonals. And one thing you should know about rhombus is, maybe you don't remember, is that side is equal to that side, and this side is equal to this side. X is actually the midpoint of the diagonals here, although I'm not sure if that comes into play or not. Name a single vector equivalent to this expression. So I'm going to mark up my diagram and then get rid of it. So you'll just have to be patient here. Don't mess up your diagram, otherwise it'll just, well, it'll be messed up. There's MQ, right? Here's MP. We want to subtract them. Oops. We want to subtract them. Well, how do we subtract vectors? Is we add the opposite. I'm going to get rid of this MP, get rid of it, and I'm going to add the opposite vector. What's the opposite of MP? Well, it's this vector PM. Right? One was going one way, the other one goes the other way. This is PM. Now, if I had to add these two vectors together, That's pretty darn easy because I can start at the start, tip to tail, and at the end. The answer is right here, isn't it? The answer should be PQ. I want to show you how, in letters what we did. What do we do in letters? Well, we're thinking of what vector is the opposite of MP. And it's easy when they're labeled like this because you switch the order of the letters and then you get the opposite vector, right? The opposite vector to MP was PM. And that was a bit of a mess. Let me rewrite that so it's nice and clear. Right? And then suddenly, now I've got an addition of vectors. And these letter ones are pretty easy then. And again, I'm looking to place the two vectors tip to tail, so I'm going to change the order of them. And I get PQ. There's the tip to tail in the middle, and it's all good. All right, and that's a letter way to do that. I'm going to clean up my diagram, and we'll do the second one. How am I doing for time? Maybe we'll stop there. But we'll come back and do B and then example 4, okay? Oh, we've got example 5 too. Yeah, let's stop there.